Hi, we'll be starting at 2 sharp today because there's a lot I want to go through. Okay, so we missed like 2 classes, right? So there's a lot I want to cover in this class, so I might go a little bit faster and probably not ask as many questions. Is it okay with you guys if I like speed it up a bit this time? All right, I guess we can get started now since most people are here. First of all, as usual, I'm going to go through the homework first. Pretty quickly, I think it was pretty simple. It was just 3 exercises, maybe a lot of questions in each exercise, but the questions are all pretty simple. So can you guys hear me and see my screen? Okay, I didn't catch that. Right, so I think we all should have not many problems with addition and subtraction and everything like that, since we've already had a lot of practice with other different units like kilometers versus meters and things like that. But just in case, I'm going to go through the answers here. So I've already written them down this time. So here the answer is already given, but for the others, with enough practice, you'll be able to do this in your head really quickly. Like you should look at 450 and 550. 450 and 550 and know that that adds up to 1,000. Just off the top of your head, because if you get enough practice, then you'll come across a lot of questions like that, and then you'll just know instinctively, basically. So here the answer is 3 liters and 0 milliliters because these add up to 1 liter, so we can change that to a 3. Okay, so this is the same thing basically. So 750 plus 400, we can add the liters first, except there are no liters here. 750 plus 400, that's 1,150. Like I said, you can do this in your head really quickly with enough practice. But if you're not sure, just write it down, like 750 plus 400. So you have to be sure about it because with mental calculation, you can make a lot of careless mistakes. So anyways, here the answer is 4 liters and 150 milliliters, and the rest I won't be going through. So the rest I won't be going through. So for the addition part, so you can take a screenshot if you want, or like write the answers down.
Oh my god.
And I suppose I will be moving on to the next page. Okay, so sorry. These should be pretty simple as well. Basically, you just take the liters and subtract them, and the milliliters and subtract them. Here they already did it for you, so you know that it's 3 liters and 180 milliliters. For this, it's basically the same thing as the part A above. It's 820 minus 780, which gives us 40 milliliters. So our answer is 4 liters and 40 milliliters. This one is a bit different. We have to convert one of these 5 liters into 4 liters plus 1,000 milliliters, if that's the method you choose. And then you take 1,000 milliliters plus 30 milliliters, 1,030 milliliters, and then you take away 360 from that, which gives you your answer here, 607 milliliters. This should be pretty simple as well. it's 5 liters plus 1,000 milliliters. So 1,000 minus 50 is 950. The rest, it's pretty much the same, except with like extra liters in the front. 3 liters minus 1, 800 minus 650, and so on for the rest of the questions. Are there any questions? Okay, I guess not. Right, so 1 liter and 950 milliliters is the answer for this question 1, part A. So basically, you have to read the question really carefully for this one. The jug holds more water. How much more water than the water bottle? So we take 3 liters and take away 1 liter and 50 milliliters from that. Total capacity, remember capacity means the greatest amount of like liquid a container can hold. So it's 3 liters plus 1 liter and 50 milliliters. Okay, for this question, it's pretty simple. So we can just take tin A and take tin C and then subtract them. So 5 minus 3 equals 2. And for this one, you don't have to put the liters there because the units are already written here for you. So the total capacity, again, it's A plus B plus C, which we know is 10. And yeah, so we know that the total capacity is 10 liters. Why does it keep doing that? The total capacity is 10 liters. So if you use this much, then we take away that much from the original 10 liters and we're left with this much, 1 liter and 600 milliliters. These word problems, you should be pretty simple as well. You just have to read the question very carefully. 300 of milk, 375 milliliters of milk in 1 packet. So in 6 packets, there will be 375 milliliters times 6. You can write packets here if you want packets, but I usually don't because it's not like a real unit, I guess. So then we get the answer, but our answer is in milliliters and they wanted liters and milliliters. So here is our final answer. 2 liters and 250 milliliters. 4 tins of paint, each with 3 liters inside. So again, we have to take 3 liters and multiply it by 4. You can just write 4 tins, but again, I usually would not. Equals to 12 liters. So after painting his house, he had this much left. So how much did he use for painting his house? Obviously, we should just take that amount left from the original 12 liters. So we're left with 9 liters and 550 milliliters. We skipped exercise 24, I believe. So our next homework exercise was exercise 25. This one is pretty simple as well. You just look at the graph and answer the questions. First of all, as I explained last lesson, I like to write the numbers above each bar. So this is 15 and this is 10, 11, 12. We know that each marking is 1 because from 0 to 5. Sorry, I think someone has their mic on actually. Is there a question? Okay, I guess not. So I know each marking is 1, right? Because there's 5 markings here. 1, 2, 3, 4, 5 and the number here written is 5. So we should know that 5 divided by 5, each 5 of these little spacings here is 1. So each spacing is equal to 1. And that's how we can figure out that this is 10 plus 1 is 12. Likewise for Mary, 15, 16, 17, 18. And this one is 17 and this one is 9. So here we can just answer the questions directly. Debbie read 12 books, as we can see. Mary read the most books because her bar is the highest, but of course you could just compare the numbers directly, even without the bar graph. And she read 18. So Waylene read the fewest because Waylene's the lowest here. The other questions should be quite self-explanatory, I think. Yeah. These questions should also be pretty simple, so you can just write that down. I won't really be going through it. Yeah. For this question, okay, this question, the last part E, might have been a bit hard because it's kind of a question that we haven't really seen before. So if Rosalie gave David how many stamps, they would each have an equal number of stamps. So David currently has 100 stamps and Rosalie has 420 stamps, right? So how do we make them have an equal number of stamps? We're going to take this distance right here, the difference between Rosalie and David's amount of stamps, and then cut that directly in half, right? We can't do that with our eyes because that's just not very accurate, but we're going to do this mathematically, because if he gave away this much over here, they'd have the same amount, right? Because this amount is the same as this amount. So to find out how much this is, we need to take the difference right here, and we know the difference because it's 420 minus 100, right? So that's 320 difference, right? So if this is 300 and this is the same thing as this is equal to this. So one of these would just be 320 divided by 2 equals to 160 stamps. So basically the answer here is 160, because if he gave 160 stamps over here, then he would also have 100, the original 100 plus 160 stamps. You can check this by saying like 100. David has 100 plus 160 equals to 260 stamps. And now Rosalie has 420 minus 160, which also gives us 260 stamps. So we fulfill this condition of each having an equal number of stamps. That's basically all you need to know for this question. I know this, you might not have seen this kind of question before, but you will get used to it eventually with enough practice. Okay, I think that was the last homework exercise, right? It's exercise 25 is the last one I gave you, I believe. So yeah, are there any questions for the homework? Like if you want me to go to like a previous page so that you can write it down or take a screenshot, then feel free to ask. And otherwise, I will move on to our lesson for today. So today I want to try and cover 3 topics: time, geometry, and area and perimeter. Because last week and the week before that we didn't have class, so I'm trying to catch up on lost time right now. Okay, so you might have noticed that I skipped the fractions topic, which I'm going to leave for next week because fractions is a pretty big topic, and I feel like some people might have a few more questions about it, so it might take up a bit more time. So let's just try these 3 topics first. So first of all, let's try time. Hours and minutes is our first subtopic of the time topic. So do you guys know how to read clocks, like 12-hour clocks?
Can I say something?
Yeah.
I just want to say Happy New Year. Mama,
oh yeah, absolutely. Happy New Year to you guys too.
It's Happy New Year. I mean, it is the year of the tiger now.
Mm-hmm. Yeah, Happy New Year, and we didn't see each other for Christmas either. So like, Merry Christmas. But that's a really late Merry Christmas, but it's okay. Anyways, can anyone help me answer these questions, just read these times for me, if you know how.
Can
Okay,
I?
dead silence. Oh, yeah, sure.
I think it's 2:05.
Yep, correct. For the first one is 2:05, exactly. So for the rest of you who are not sure maybe how to read a clock, that's not a perfect circle, but so 12, 3, 6, 9, right? And then 1, 2, 4, 5, and so on. It's kind of an ugly clock, but so the hour hand is the short hand, right? Sometimes on most clocks is a bit thicker than the minute hand. The hour hand is points to the hour, so we can just, if it's pointing here, then it's 1. If it's pointing here, then it's 2, and so on. We don't, on 12-hour clocks, we can't really tell the difference between AM and PM, so we'll just have to live with that for now. But yeah, as for the minute hand is the long one. It's quite a bit longer than the hour hand. So if it's pointing to 1, it's 5 minutes. And if it's pointing to 2, then it's 10 minutes. 3, 15, 4, 20, and so on and so forth. If you ever forget, you don't have to like memorize all these numbers, obviously, because if you notice, it's just 1 times 5, 2 times 5, 3 times 5, and 4 times 5, and so on.
It's the 5 multiplication table.
Yeah, exactly. So 5, 10, 15, 20, 25, and so on and so forth. You guys should know the rest. So how to tell the time? Now that we know what the hour hand and the minute hand are, and oh yeah, for minutes in between, like 7 should be around like, okay, 5, 6, 7, 8, 9, and 10, right? So 6, 7, 8, yeah. Here's 5, and here's 6, and here's 7, and here's 8, and here's 9. Correct? And you can do that for the rest of the intervals as well. If the minute hand lands here, then that means it's 7 minutes, right? And if it's here, it's 8 minutes. And then like around here,
Hello? 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 Hello, 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 hello? I think the teacher froze.
Sorry guys, I think my Wi-Fi was just very bad just now, so it got cut off the whole thing. Can you guys see my screen now? And like hear me?
I can hear you, but don't see the screen.
You don't see the screen. Okay.
You're not sharing your screen.
Right, sorry. I'll try that again. Can you see it now? Can you see me like switching through these two slides? Okay, you can see? Okay, good. Where did I assume that I just cut off right before the screen broadcasting stopped, so I'll just continue from there. So I was explaining earlier that 4 here, it's past 4, but not, the hour hand here is past 4, but not reaching 5, right? So, and the minute hand is pointing to 15, therefore it is 4:15. And then for the other two examples, it's past 12, not reaching 1, so it's 12 something, and minute hand is pointing to the number 4, and 4 times 5 is 20. So it is 12:20 right now. Not right now, in the question. For the other one, yeah, 7, it's past 7, not reaching 8, and the minute hand is at 30, so it's 7:30. Okay. Now we're talking about calculations, kind of. 26 minutes after 9:30 a.m. So the clock here shows 9:30 a.m., right? The top left one, because it's past 9 and the minute hand is reaching 30. So 26 minutes later, it's originally like around here, right? So 26 minutes later, this would move almost half of the way, almost like half of the circle. But since it's 26 minutes instead of 30 minutes, it's not quite halfway yet. So we'd end up around here. And that's in one of the spacings between 11 and 12, right? And if you look closely, so if 11 is 55, then the one just past that would be 56. So here we have, and you notice that our hour hand just moved a bit, right? Because that's just like progressing through the hour. So now it's almost reaching 10 because 56 minutes is very 56 minutes is very close to 60 minutes. Basically that's how time works, I guess. If you didn't have a clock right here, basically you're not supposed to like add times. Like you can't say 9:30 plus 26 minutes, because that's just wrong. You can't add a duration to a time. You can't add a time to a time. You can only add a duration to a duration. What that means is you can only add like minutes plus seconds, or hours plus seconds, or hours plus hours, and so on and so forth. But you can't add like 9:30 a.m. plus 26 minutes. So how do we do that? How do we show our workings here? It's 9:30 a.m. 9:30 a.m. And right above here, 26 minutes. So 26 minutes past 9:30 a.m., we look at the minutes here and we add 26. So here our answer is 9:56 a.m. We got lucky because 56 is less than 60. But sometimes, like for example, if this value was 36 minutes instead of 26, then we'd end up with 30 plus 36 equals to 66. And that's over 60. So that's not good, right? So we can't have 9:66 a.m. So what we need to do is we need to take these minutes, and we need to convert them into 1 hour. 66 minutes equals to 1 hour and 6 minutes.
Can I say the time now?
Yeah.
The time now is 10:06 a.m.
Yeah, exactly. So we take this 1 hour and then we add it to the 9, but we can't like write 9:66. That doesn't even make sense. So it's 10, and then we take the 6 minutes. Don't forget the 0 in front, because time always has like two numbers at the back. So we can't write 10.6 because that wouldn't make sense. Right, so for the next question, how many minutes? Again, we can draw a timeline here. This is called a timeline. So 1:15 p.m. to 1:42 p.m. I like to put the times on the bottom and the durations on top. So like minutes and hours go here, and then like something p.m., something a.m. goes here. Okay, so this, we just look at it and we think, so how many minutes from 1:15 to 1:42? So it's 1 hour 15, 1 hour 42 minutes. So we take 42 minus 15, which is equal to 27. 27. So here we have 27 minutes here. 27 minutes, and yeah. 9:15 to 11:30.
Can I go to the bathroom?
Oh yeah, sure. Okay, for the last question, part C, 9:15, 11:30. So here we can look at the hours first. We look at both the hours and the minutes, and we see 9 to 11. Actually, I think we should look at the minutes first in this case. So 15 to 30, that's 15 minutes, right? 15 minutes from 15 to 30, because 30 minus 15 equals to 15. And 9 to 11 is 2 hours, right? Because 11 minus 9 equals to 2. So the answer here is 2 hours and 15 minutes. So if this number was smaller than this number, like say if it was 11:10 a.m. instead of 11:30, sorry. Then we can't directly take this and subtract this from it, right? Because that's bigger than that, and we can't do that. So what we need to do is say write this as 11 hours and 10 minutes. And then we take 1 hour from that and put it into the minutes. It's like the reverse of what we did just now. Out there. Like the reverse of what we just did just now. 10 hours and 70 minutes, because we're adding 60 onto that, since we took 60 minutes from 1 hour. So with this 70 minutes, we can take away the 15, right? So that's 55. 55 minutes. So we can write that up here. And 9 to 10 is only 1 hour, because 10 minus 9 equals 1. So our answer here is 1 hour and 55 minutes. It's pretty much the same as like your kilometers and meters and your liters and milliliters, but it's a bit different because just with the kilometers, you have 1,000, like 1 km equals to 1,000 n, right? But here we have 1 hour equals to 60 minutes. So we can't divide it by 10 the same way, but we know how to divide by 60, right? Or like multiply by 60, not divide. Yeah. So it's like 6 times 10. So if you want to like divide it by 60, then you divide by 6 first, and then you divide by 10. And if you want to multiply by 60, then obviously you can just times 6 times 10. Right, so here we have the answers that we got just now, except for the last one because I did something different. Let's move on. So here is our conversion that I was talking about just now. So 2 hours equals to how many minutes? So we know that 2 hours, 1 hour equals to 60 minutes, right? So 2 hours is 60 times 2, 120 minutes. Pretty easy. 2 hours and 10 minutes, we know what 2 hours is, so we just add 10 minutes onto that, so it's 130 minutes. 3 hours and 50 minutes, again, 1 hour is 60, so 3 hours is 60 times 3, which is 180 minutes. And then we add that 15 on, so it's 195 minutes. This should be pretty simple, but if you have any questions throughout this lesson, feel free to let me know. I'm going to try going faster because we still have a lot more to cover. Right, in hours and minutes, this should be pretty simple, right? So 70, you divide that by 60. And how you do that is you divide by 6. So I'll just demonstrate one question. 70 divided by 6, 6 goes into 7 one time, minus 6 is 1, so we add that 0 on to become 10, and 6 goes into 10 only one time. So our remainder here is 4. And okay, 11 divided by 10. Sorry. Okay, I don't think the division actually works when it's separated. So basically, what you need to do is find how many times 60 can go into this number, right? So 60 goes into 70. 60 goes into 70 only one time, because you can't just add another 60 to that, because then it becomes 120, which is obviously greater than 70. So if it goes into it one time, our remainder here is 10. So in hours and minutes, 70 minutes is 1 hour. 1 hour from here goes into that one time, and 10 minutes, since our remainder is 10. 125, same thing. 60 goes into 125 two times, right? Because 60 times 2 is 120. And then the remainder here is 5. So it's 2 hours and 5 minutes. The other one should be pretty simple. Why did I write 3 hours? That should not be 3 hours. That should be 3 hours and 30 minutes, I believe. Okay, moving on. Yeah, that's the timeline I was talking about just now. You might notice that they write 12 o'clock noon instead of like PM, but 12 o'clock PM is also right. It's the same thing basically. And 12 o'clock midnight is also 12 o'clock AM. I think noon and midnight are technically more correct than AM and PM, but I don't think it really matters as long as you know what you're talking about. Basically here we're finding the duration, which is the same thing as what we did just now with the clocks, but this time we don't have clocks. So here, 12 o'clock noon and 2 o'clock PM. So how many hours is that after? Because 12 is basically, you can think of 12 o'clock as like a starting point. So from 12, both the hands are up, right? And 2 o'clock is, the hour hand is at 2. So you notice the hour hand has moved 2 numbers, right? So our answer here is 2 hours. The others are pretty similar. So 12 noon as our starting point, and then 1 o'clock, and then 2 o'clock, and then 3 o'clock. So that's 3 hours, but they're asking for 3:30 p.m., not 3 p.m. So we have to add 30 minutes back on. So that's 3 hours and 30 minutes. As for before, the last question they asked, this is before that. So 12 o'clock noon and 10:45 a.m. So basically, we're just doing the subtraction again, but as you notice, 0 can't subtract 45, so we can convert that into 11 hours and 60 minutes. 60 minus 45 is 15, and 11 minus 10 equals to 1. That's 1 hour and 15 minutes. And it might seem a bit confusing at first, but honestly, I think if you just use like common sense, I guess it should be fine. Other units of time, I don't think we can go through this because we don't have that much time left. Haha, time. But you should know this, right? As long as you know that like 1 minute equals to 60 seconds, you should be able to do the rest of this. And then years and months, 1 year equals to 12 months, and for weeks and days, 1 week equals to 7 days. Months and days is a bit different, but apparently you're not asked on that right now. So you don't have to convert between months and days, I'm pretty sure. Because some are 30 days and some are 31 days, some are 28 days. It's weird. Okay, moving on to the next chapter because we have 22 minutes left and that's not very much. Does anyone have any questions, by the way? Okay. Geometry. So geometry at your level isn't really like real geometry. It's basically just talking about angles, right? So an angle is when you have 2 lines that do that. So this is an angle, and this is an angle, and this is an angle, and this is an angle. And if you have a shape, like just a random shape like that, this is an angle, this is an angle, this is an angle, this is an angle. Sometimes this can also be an angle, but Yeah, we call this an 180-degree angle. We haven't learned measurements and degrees yet, so I'll leave that alone for now. So yeah, basically an angle is like the measurement of how big like this thing is. This is a smaller angle and this is a bigger angle. This is a bigger angle. This is also a very big angle. In fact, this is bigger than that, even though the lines are shorter. And this is a very small angle, even though the lines are very, very long. So the angle has nothing to do with the length of lines, right? It's just that, and that. Okay, so a right angle is a 90-degree angle. And it's just a perfect that and that. There's a term called perpendicular. So this line has to be perpendicular to that line to form a 90-angle degree. 90-angle degrees are usually marked as like this square thing instead of a usual like circle thing. I can't draw it like really accurately right now because I don't have a ruler. But yeah, so like a right angle, like for example, the corner of a piece of paper, maybe. That's a perfect right angle. And like the corner of like say a ruler, unless it's like curved or something, then that's a perfect right angle. There are other examples like corners of tables, just like any perfect corner. That's not like this, and it also can't be like this. That's not a right angle, that's not a right angle. This is a right angle. I think you got it. Okay, so which of the following are right angles? This one, A is definitely not a right angle, right? Because it's too big. It's too big. Angles that are bigger than right angles, this would be a right angle. This angle is called, an obtuse angle. Obtuse angle. And then if that's a right angle, this angle here is called an acute angle. It's smaller than 90 degrees. So you don't have to know that for now though. So A is definitely too big. B seems quite right? So I think that's a right angle. I don't have like a set square or anything with me, so I can't know for sure. But C also looks pretty like that, right? So D also looks like a right angle. E almost looks like a right angle, but if you notice, it's a bit smaller than a right angle, right? Like if you tilt your head a bit, then you can see that it's not quite a right angle because I can't annotate on this. A right angle would be, yeah, a bit bigger than that. So E is not a right angle. F looks like a right angle. So yeah, here, how many angles does each of these figures have? Okay, so for P, we have 1, 2, 3, 4, right? And we can tell from looking that this is a right angle. Q has, okay, we can obviously tell that this is a right angle. It looks pretty straight, but you probably might have missed that this part here is also a right angle. So Q has 2 right angles, and in total it has 1, 2, 3, 4, 5 angles. For now, we're only counting the angles within the shape. We're not counting like the outside angle, because we don't need to know that right now. And then R, we have 1, 2 right angles, I believe, and then 1, 2, 3, 4 angles that can be right or can be not right. And then S, we have 3 right angles and 5 angles in total. Okay, so that's pretty much all you need to know. You don't have to do anything with these right angles for now. So just enjoy. Moving on to chapter 9, area and perimeter. Let's talk about area first. So area, I remember mentioning this in a while back, but like I said that if you have like the counting things, like if you wanted to count these boxes, instead of just counting one by one, you could also just take this length and see 1, 2, 3, 4, 5, 6, 7. 7 times 1, 2, 3, 4, 5, 6. 7 times 6 would give you the total number of these boxes inside. So, okay, we're starting off with some weird shapes. What is the area of each of the following figures? A, we know A should be pretty easy, right? 1, 2, 3, 4, 5, 6. So A's area is 6 square units. Since each of them is 1 square unit, A is 6 square units. And then for B has these weird triangles, right? Like that. So you can see that each of these triangles is half a square unit, because if I take this and I move it over there, that makes up 1 square unit. So we can take these two triangles as 1 square unit. So 1, 2, 3, 4, 5. The answer is 5. The area is 5. For C, you can just count, so it's 13. D, what I like to do is I like to count the triangles. I like to count the triangles by 2. So like 1, 2, 3, 4, and then these would be 5. These would be 6. Alternatively, you could take 1 plus 1 plus 1 plus 1. That's the squares here, right? And for the triangles, we can say that they are half. So plus half, plus half, plus half, plus half. Because since there are 4 of them, half and half makes 1, and half makes 1. So it's 1 plus 1 plus 1 plus 1, plus 1 and plus 1. So our answer here is 6. Oh, there were 2 other questions. Which one has the smallest area? We know that it's B, since we only counted 5, and which has the greatest? C, because it was 13. Yeah. What is the area of these? Okay, so here we want to talk about units a bit more. So for units of area, we know that for length and distance, it's centimeters, right? In this case, centimeter. This is 1 centimeter, and this is 1 centimeter. So if you have a square like that, the area of this is 1 times 1. What's the unit of that? 1 cm times 1 cm. We call it a centimeter squared. Square centimeter. Basically it has just a tiny 2 at the top, which means that it's a unit for area. This is length, and length times length equals to area, right? So yeah. Later you'll learn about volume. So that's a 3 right there, and it's like volume of 3D objects like cubes and stuff. We don't need to talk about that right now. Okay, so for A, it's pretty self-explanatory. You just count the squares. 1, 2, 3, 4, 5. 5 squares, so it's 5 square centimeters. You can say centimeters square or square centimeters. I don't think it really matters, but either way, it's written as cm with a small 2 at the top. B is pretty much the same thing as what we did just now. Just count the squares and then count the triangles. And since each of the triangle is half a square, we just take 1 square for each 2 triangles. C, we have a new shape here. So there are these 2 half squares, right? But they're not the same half as the triangle. But they are still half a square, essentially. So if I move that there, it would take up 1 full square, and this is no more. So we can just count these 2 weird rectangles as 1 square. So C is, that's 1 square. So this is 1, and this is 1, and this is 1, 2, 3. 1 plus 1 plus, so 1 plus 1 plus 1 plus 1 plus 1 gives us 5. D, same thing. Okay, E is weird. E is very weird, because E, you have these weird things, right? Because what is this? You can't just take this on its own. That's not half. I don't even know what that is. Well, you can calculate it, but we can see that this triangle, this long weird triangle, takes up half of 2 squares. So we know that this is equal to, so this isn't part of it. This triangle here is equal to 1 square because it's half of 2 squares, which is basically just 1 square, right? And then likewise for this, the other weird triangle, it's equal to 1 square. And then for the other 2 triangles, you can just take them as half. And then for squares, you just count them on their own. Yeah, and these are the answers. You can take them down if you want. Okay, for these it's also the same except in meters. So meters times meters equals to square meters with the small 2 on top as well. Yeah. So basically this is pretty much the same thing, different units. Okay, now we're talking about perimeter. Perimeter, they have the same area, right? So it's 1, 2, 3, 4, 5, 6. It's made out of 6 squares. So the area of each figure is 6 squared centimeters. However, their perimeter is different. So if I were to, okay, that's shape A, right? So the perimeter is the outside of it. And it's in length, which means it's in centimeters or meters rather than meters square meters or anything like that. So we just count basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the perimeter is 12 centimeters for shape A, figure A, right? I like to trace along where I count because sometimes if you don't trace it, then you just lose where you are and you might end up recounting some shapes, some parts. So yeah. Okay, so this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. No, there's no 15. Let's try that again. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So our answer here is 14, right? Basically, perimeter is the outside edge of the thing. Remember, our units are in centimeters rather than centimeters squared. Yeah. So even if 2 figures can have the same area, the perimeter might be different. For these, they already give you the lengths of each of the sides, so basically you just add them up, right? So 8 plus 7 plus 10, and then that's the perimeter for A, and then 7 plus 9 plus 6 plus 12 is the perimeter for B, and so on and so forth. I have the answers right there. And we are running out of time, but we only have a few questions left after this, so yes. Let's talk about area of rectangles, right? That's what I was talking about when I drew the boxes here, remember? So there are 2 people here. One of them counts the square units covered by each rectangle to find its area, which you can also do. Like for example, if you have a 3 by 4 rectangle, you can count these squares, right? 1, 2, 3, 4, 5, 6, 7, 8, and then eventually you'll get to 12. So it's 12, the area here is 12. Alternatively, you can just take 3 times 4. 3 times 4 equals to 12. So that's the length and the breadth. Length, it's actually pretty ambiguous, usually which side is length and which side is breadth. But you just need to know that just take one side as length. Like for example, here the length would be 4, and the breadth is 3. Alternatively, you could call breadth like width. It's the same thing. Yeah. Okay, here, that's the exact example for part A. So 3 times 4, and then here we have 3 times 6 for part B, which is 18. Don't forget the units, it's 18 square centimeters, not 18 centimeters. And then 4 times 6, sorry. With questions like these, they don't give you squares to count, right? So your only choice is to take 4 and multiply by 6. So which gives you 24 centimeters squared. 3 times 9, same thing. 8 times 20. 8 times 20, I'm not sure if you like forgot how to do it or something, but 20 times 8 equals to 8 times 2 times 10. So 8 times 2 is 16. You know that from your multiplication table. 16 times 10. Just add a 0 at the back. 160 centimeters squared. Yeah, that's basically it. So for the rest of the time, I'm going to give you your homework. Yeah. I'll stop sharing my screen now. Yeah, okay. So your homework for, I forgot to turn on my video, sorry. Well, it doesn't really matter since you guys were looking at my slides anyway. So for your homework, it's going to be workbook part 2 instead of part 1. So it's workbook 3B part 2, exercises 39, 46, and 52. Pretty weird numbers, but yeah, I'm just trying to get one exercise from each topic that we covered today. So again, that is 39, 46, and 52 from workbook 3B part 2. And with that, you are all free to leave, I think. If nobody has any questions for me, then I will, yeah, then we're dismissed for today.
Bye.
Bye-bye.
Bye. Bye.
Bye. Okay, so I suppose I will end the meeting now if there are no questions. Okay. Bye-bye.